Our story begins not in a university, but here, in the hiss and clatter of the Industrial Revolution. The engineers had built a marvel, but the question of why it worked would lead us to the very edge of reality. The practical question, how to build a better engine, would soon become a cosmic one. A small group of thinkers were about to discover the hidden laws of energy itself. The first engines were crude, atmospheric beasts that gulp coal and wheeze steam. They worked, but no one knew why. Efficiency was a mystery. Waste was everywhere. Carnot imagined the perfect engine. He realized heat did not produce work by being consumed. It produced work by falling from a high temperature to a low one, like water falling over a waterfall. This was the first true law of thermodynamics. No real engine could be more efficient than Carnot's ideal. The gap between hot and cold was the engine of the world. Carnot died young. His notes, hinting that heat was not a fluid but motion itself, were burned to stop the spread of cholera. His ideas waited decades to be rediscovered. Yes. Joule proved a radical idea. Work and heat were the same thing. A falling weight churning water produced a precise amount of heat. He found the conversion factor, 772 foot-pounds per British thermal unit. Heat was not a mysterious fluid called caloric. Heat was energy, mechanical energy. A brewer had discovered a fundamental law of the universe. With Carnot's theory and Joule's data, the stage was set. Two men, Rudolf Clausius in Germany and William Thomson in Scotland, would unite the engine with the cosmos. In our first chapter, we followed Joule as he measured the mechanical equivalent of heat. We saw him prove that heat is energy. But one question remained unanswered, a question that would tear the world of physics apart. What is entropy? Clausius gave it a name, probabilities, and the arrow of time itself. But no one could see it, no one could touch it, until a man with a magnet into the dance of atoms and saw the face of probability.
Entropy.
Entropy, the most misunderstood concept in all of physics. It is a measure of how many microscopic arrangements correspond to the same macroscopic state. Internal energy, enthalpy, entropy, Gibbs free energy. These four functions are the language thermodynamics uses to speak. They tell us what happens. They do not tell us why. For that, we need to look deeper. We need to look at atoms. We need to look at probability. We need to look at Ludwig Boltzmann. Before we climb Boltzmann's mountain, we must first build the cathedral. Why build the cathedral first? Because without the laws, Boltzmann's atoms are just ghosts. Without enthalpy and entropy, his probability is just a guess. The cathedral gives us the language. Boltzmann gives us the vision. You cannot have one without the other. So trust me, learn these laws, feel these functions, let the cathedral stand firm. Then, and only then, will Boltzmann's mountain be worth the climb.